We are going to do Chapter 1, Section 9, or Section 1.9. Before you attempt any of the exercises at the end of this section, you want to make sure that you understand the material in the chapter, in the section, in particular Table 16, where they talk about properties of inequalities, and Table 17, where they talk about properties of absolute value. So let's get down to some exercises from the end of this section. So this is section 1.9. Let's start with number 28. The instruction for number 28 says, find the values of x that satisfy the inequalities. And number 28 is 2x minus 1, x plus 2 less than or equal to 4. One way to solve this, and you have seen this in the text of the section, one way to solve this is to take the 4 from the right-hand side and put it to the left-hand side, so you would have this as less than or equal to 0. So you would have 2x minus 1 divided by x plus 2 minus 4 less than or equal to 0. Now here, if you take the common denominator, you would have x plus 2. The numerator would be 2x minus 1 minus 4x minus 8 less than or equal to 0. You simplify the numerator. The 2x and minus 4x would give you minus 2x, and you have minus 1 and minus 8, which would give you minus 9 divided by x plus 2 less than or equal to 0. Now here we're going to use the number line to continue finding the answer for this equation. What we do is, for this inequation actually, what we do, we set the numerator and denominator each equal to 0 and solve for x. So you have minus 2x minus 9 equal to 0. Therefore, minus 2x equal to 9. Therefore, x is equal to minus 9 half. This is 1. And on the other hand, for the denominator, x plus 2 equal to 0. X is equal to minus 2. These are the values which would make the numerator and denominator equal to 0. We're going to use the number line here. Put 0 in the middle. You go to plus infinity this way, minus infinity this way. We're going to show minus 2 first. Let's say this is minus 1, minus 2, minus 3, minus 4, minus 5, and so on and so forth to minus 6 and on. First, for the denominator, for x equal to minus 2, the denominator is 0. So you put here 0. For x greater than minus 2, the denominator would be positive. So we put positive to the right-hand side. For x value less than this minus 2, the denominator would be negative. So put negative. Now the numerator, for x equal minus 9/2, which is 4.5, minus 4.5, which is up here, the numerator would be 0. Down here, of course, is minus 9/2. For any value less than minus 9/2, the denominator would be positive. For anything above minus 9/2, it would be negative. Now, we look at the problem, and it says we want this quotient to be less than or equal to 0, which means we want it to be negative. Okay? We look at our number chart, and we would see for values to this side, plus times minus, it would be negative. To the left-hand side here, again, you have plus and minus divided by each other, it would be negative. So any answer above minus 2 and below minus 9/2, that would be the answer we are looking for. So we write x has to be less than or equal to minus 9/2, or x has to be greater than minus 2. Greater than minus 2 from this point on. In this direction, we put parentheses. Again, of course, it cannot be equal to minus 2, because when it is minus 2, denominator, as you can see, if it is equal to minus 2, this denominator would be 0, and anything divided by 0 is undefined. So it cannot be equal to. And on the other hand, from 9/2, you put bracket to the left, that would be the answer. So the only place we do not have the answer is between minus 9/2 and 2. Everything else is an answer. Let's do another problem from this same section. Problem number 46. Problem number 46. 46 says, write the inequality x minus a greater than or equal to b without using the absolute value, using the absolute value. Well, based on the property of absolute value and inequality, this can be written as x minus a greater than or equal to b, or x minus a less than or equal to minus b. Either way, it would be the answer to this inequality. So here it would be x greater than or equal to a plus b, and here would be x less than or equal to a minus b. These are the two answers. Let's look at two more problems from this section. Problem number 58, which is an application problem. Problem number 58. It says markup on a car. The markup on a used car was at least 30% of the current wholesale price. If the car was sold for $6,500, what was the maximum wholesale price? Okay, so first we have to define the markup. Let's see, number 58. Markup in this example is what do we call it? The price minus wholesale divided by wholesale. This is how you define the markup. You want this to be at least 30%, so you want this to be greater than or equal to 0.30. Now, if we say wholesale is X, variable X, then this quotient, price, which is $6,500, minus X divided by X has to be greater than or equal to 0.30. You multiply both sides by X, that means 6,500 is 6,500 minus X is greater than or equal to 0.3X. If you take all the X's to one side, you get 1.3X less than or equal to 6,500. Divide both sides by 1.3. Divide both sides by 1.3. That means X, which is the wholesale price, is less than or equal to 6,500 divided by 1.3 is 5,000. So the wholesale price would be at the maximum $5,000. That's the answer to this. Okay, let's move on and do another problem from this section 1.9, and that is problem number 64, which has to do with quality control. The problem says the diameter X in inches of a batch of ball bearings manufactured by PAR Manufacturing satisfies the inequality. Let me write this down. This is number 64. The inequality is X minus 0.1 less than or equal to 0.01. What is the smallest diameter a ball bearing in the batch can have, and what is the largest? Again, looking at the properties of inequality and absolute value, we know that this, without the absolute value sign, can be written as X minus 0.1 less than or equal to 0.01, or, I'll open up another column, X minus 0.1 greater than or equal to minus 0.01. If we solve this, we get x less than or equal to 0.11, and that's 1 limit, and then x here would be greater than or equal to 0.09. That's another one. Therefore, this is another way you express this. X would be between 0.11 and 0.09. So you have a maximum, which is on this side, and you have a minimum. So the maximum would be 0.11 inches, the minimum would be 0.09 inches.